Okay, so this is part 1. We're going to split this PowerPoint into 2 days. So we're going to cover about half of your PowerPoint today and the other half on Monday. And this PowerPoint will cover, like I said, most of the information that you will see on your final exam. We also do have the practice test that will help you as well, that you can go back through while you're studying for your final. You can go back through those practice tests as well. All right, so your final exam is multiple choice. How many of you have taken a multiple choice test before? All multiple choice. Okay, well, you should all raise your hand because you all just did the MAPS test, right? And that was multiple choice. So what we know is that any type of standardized test that you take, whether it's MAPS, SAT, ACT, it's going to be multiple choice. So you learning how to take that kind of test is really, really important. All right, so here's a couple reminders for you. Don't stare at a problem, especially at the beginning. So let's say you get to number 2 on your final and you're like, oh my goodness, I'm not really sure how to solve this, or I think I know, but I'm not 100%. I would circle it and come back to it, because every question on your final is worth the same number of points. The most difficult question on your final is the same number of points as the easiest question on your final. So it's very important that you don't just get stuck on a problem, especially early on in your test, because guess what's going to happen? You'll end up with 10 minutes left and you have 20 questions left to solve. That's what you don't want to happen. If you move through the test, do like a first go around on the test and just go through and circle your answers. When you go back through, now you can focus on the problems that actually require some work, okay? The other strategy that I wanted to talk about, okay, is the strategy of eliminating the choices that you know are irrational. So you're taking a multiple choice test, right? Have you gone through the choice options and said, oh yeah, that one's definitely not it. That one's definitely not the answer. Process of elimination. If you can say, yeah, option D, like there's no way it's option D, then that increases the likelihood, are you ready for this, that you could actually guess the correct answer if you did not know how to do it. However, hopefully there will be no guessing on my final. What do you think is going to happen if you have to guess on a lot of questions? You're probably not going to do too well, okay? So the goal is not to be a good guesser. However, if you happen to guess the correct answer, you get the credit on a multiple choice test. SAT, ACT, they don't care about your work. Can you get to the correct answer? All right, so with that in mind, I want you, as we are going through these questions, guys, think about this. Listen, okay? I want you to think about what could potentially be some answer options that would be in a multiple choice question like this. What are some common mistakes that you think could happen when you're solving these problems? Okay, so if you can think about it from that perspective, it will help you with your process of elimination. All right, so to start, I'm going to have you guys simplifying these rational numbers. So we're dealing with fractions in this first slide. You can work together, make sure your answers check out, because when I call on you for the answer, you will be the one who has to give the answer. And if it's correct, then obviously you can place your mark on our little tic-tac-toe board here in the middle of the classroom. Okay? All right, so go ahead and answer these 2 questions, please. Yes, both of them. All right, Madeline, what did you put for your first answer?
0.
Okay, it's 0. What do we call numbers that are opposites? What's that fancy word for them? Additive, inverse. Additive, inverse. All right, what about my second one? Someone over here give me the answer to my second problem. All right, I need your answers. I need somebody. Ethan?
36 over 77.
It is 36 over 77. How did I know that that was going to be positive? Because there's 2 negatives. Even number of negatives is a positive answer. Very good. All right, here's your next 2.
I see what you're doing.
Okay, go ahead and solve the next 2 now. Go ahead and solve the next two.
Bottom or
The two on the right. The two on the right. We've already solved the two on the left. Okay. All right, Jada, tell me the answer to the next problem, the subtraction one. Stop. Okay, what's the answer? On the subtraction one? Yes, no. I did. Okay, all right. So it is negative 11 over 4. Okay, I think some of your teammates saved you on that one. All right, over here. Let's see. Jeffrey, what did you get for your answer? Very good. Did you flip it and multiply? Did you remember to cross cancel? 3 and 4. Don't forget to keep it negative. Negative 4 over 3. Negative 4 over 3. Very good. All right. Good job on those, guys. All right. Next questions. Okay. Next question. For this group, you have to get all 3 of them correct. All right. And it will count as like one spot on the board. Okay. For all 3. And then the same thing will happen on the next set of questions. Okay, go ahead and answer these questions, please.
First one is 0.84.
0.84.
Second one is 32%. And then the last one is negative 10.
The last one is negative 10. Very good. Remember, guys, the radical is positive, but because there's a negative in front of it, it will be negative 10. Negative 10. All right, great job on that. All right, now here's your next set of problems. Hold on. All right, here's your next set of problems, the next 3 for Team B to answer. Okay, so in order to find the cubed root, remember, you do have to have these memorized. The cubed root of 1. Guys, the cubed root of 1. 1. 1 times 1 times 1. What about 216? 6. Okay, now, how did you know what would be my denominator? 4 is in the 100th place, so 100. Now, if you reduce it by, let's say you just reduce it by 2. You get 12 over 50. Do you think that would be one of the options in your answers?
Yes.
Yep. But you need to reduce it again by 2 to make 6 over 25. So you guys did good on that. Who got that one right? Okay.
Yeah, I got that right.
All right. Now, okay. So what perfect square, y'all can answer this. What perfect square is 60 closest to? So the square root of 60 is really close to 64. So that's going to be approximately 8. What about the cubed root of 700? What perfect cube is that closest to? 9. 729 is the perfect cube for 9. So 9 is going to be bigger. So that's why the cubed root of 700 is bigger. If you do not want to have to guess on this problem, the strategy is to find the closest perfect square and take the square root of that number. Or a perfect cube. Okay, all right, good job on those. Okay, here's the repeating decimal. Now, we did just review this one before class, and it's still on my board, guys. Okay, so let's try to solve this, and then we've got to catch up on our game as well. Okay, so we're just going to pause here for a second. All right, let's make one modification. That actually makes sense now. Why? Guys, listen up for a sec. Okay, so how many repeating digits do I have?
2.
How many repeating digits do I have? 1. Okay, now what can throw you off, and guys, on your final, it will be different digits, but this technically, okay, it should be 0.2 repeating, which will help you figure out what to multiply both sides by. Okay, so there's a little bit of confusion there, but I can assure you on your final, it will be very clear whether you're supposed to multiply by 10 or 100. Okay? So technically, I only had one digit that was repeating. It should have been written this way. So now, you should be able to answer it pretty quickly. Okay? All right. Sam, walk me through it. What did you do?
First I multiplied by 10.
Okay, so she said x equals 0.2 repeating. Set it equal to x. Pay attention, guys. She multiplied the entire equation by 10 because there was one repeating digit. Okay, and what'd you get?
10x equals 2.2.
Okay, equals 2.2, but that repeating is still there. And what'd you do next?
I subtracted it by the first number.
Very good.
And then I got 9x equals 2 and divided it by 9.
Very good.
X equals 2 over 9.
X equals 2 over 9. Oh, okay, very good. X equals 2 over 9. Do you guys see how we got to that answer? All right, so I know it's like, golly, like we're making this really complicated, but remember, we're trying for a method that works every time. We don't have to analyze, is this method going to work this time or that time? We know that the equation method works every time to change a repeating decimal to a fraction. Okay, so that's really important. All right, here's your next problem. I know, I'm going to. I'm just going to let you guys start working on the next problem. Okay, Saley, you have an answer? Okay, all right, here we go. So what did you do? Walk me through it.
Okay, so I added 3.25 and negative 3.25, but that cancels out.
Yes, very good. Anybody else catch the opposites?
Me.
Okay, all right, then what?
So funny. And
That's
then
so funny.
I did negative 2 and negative 1.
Yep,
And some side I keep, and I got negative 3.
negative 3, perfect.
Then I added 0.5.
Yep.
And I got 2.5. Wait.
Why don't we do 0.5 plus 4 to get 4.5?
Yes.
So add our positives. And what's the difference? What'd you get for your difference?
Well,
Negative 3 plus 4.5. Different sign.
1.5.
Yep, subtract 1.5. And what would you divide by?
100.
Not 100. No, it's okay. Tell me.
6.
Yes, divide by 6. And what would we get for our answer? Anybody want to close the deal for her?
0.25.
Yes, ma'am. 0.25. 0.25 once I divide. So that's my mean. All right. Remember, I add all my values and divide by the number of numbers in the set. All right. Great job on that one. Okay, here's your next problem, guys. Y'all talk amongst yourselves and try to figure out the next one. In this problem, it doesn't really matter because it ends up being the same number. But how do I know what goes on the top and what goes on the bottom? Well, the value that needs to be divided. Okay, so which value are you subtracting? Is it the time or the inches that you're actually going to divide by? Does that make sense what I'm asking? Let me just explain it, okay? Which values do you need to subtract from each other?
The hours and inches.
The hours, okay? So the hours, I just said that backwards. The inches, okay, inches goes on top. All right, the difference in the inches divided by the hours because I'm looking for per hour, the mean hourly rainfall. Okay, so how many inches fell within that time frame? How many inches fell?
7.
No, from 3 to 8, that is 5 inches. Okay, in how much time? 5 hours. So that would be 1 inch per 1 hour. Okay, or you could say 1 inch per hour, like PER. Again, on the multiple choice, it'll be obvious which answer option is the correct one. 1 inch per hour. Okay? If it is a steady rate, rain is falling at a rate of 1 inch per hour. Okay? That's like hurricane level. All right? Okay, good job on that one. We've got one more scenario problem. Okay, go ahead and solve this one. Okay, Ella, what'd you come up with? $3.15? Oh, you know what? Did you do 7? Did you do? Okay, yes. Okay, I'll take it. It says you go out shopping with a group of 6 friends. So how many of you, did anybody do 6? Okay, so everybody did 7. So you do want to be careful how you read that. We had the discussion in first hour, but I would agree it's 7. So then we add together how much each person spent, and we multiply it by 7, and we get $315. Okay, so it's essentially 7 times 8 plus 12 plus 25, which gives me the total of $315. Okay? All right, so just a real quick way to get to our answer. And that will be it for that one. All right, let's see what's next. We might be able to get through this one pretty quick. Okay, all right, talk amongst yourselves. We only have a couple minutes left. See if we can get through this one. It is 6. Why?
If you walk in and do samples of everything, but you still don't get anything, 0, 0. That's what you.
Okay, I mean, that could be true. All right, listen, guys, here's why it's 6. 6 is the operation happening to X to get to Y. It does not matter. Listen, please listen. It does not matter what value you plug in for X. It will always be multiplied by 6 because 6 is connected. That is why 6 is the constant of the proportionality. It is always your M value or your rate. Okay? All right, very good. All right, this is the problem that we'll leave off on for Monday. All right, we'll go over this one on Monday. It just turned 1:10, so we've got a couple seconds left. So that will wrap up what we're doing for part 1, and we'll pick up on Monday.